Hi everyone, good afternoon. Glad to be here at the DotNext conference again, and this time the online edition. I've got a lot in store for us today. I'm a cloud architect in real life. Do a lot of boxes and arrows, but I also like to get my hands dirty and like to look into new technology such as Dapr, for example. So today I have a fully packed agenda for you, which is about building a distributed application using Dapr. And let us go through all the things that we will be looking at. The idea is that we are going to build a Twitter leaderboard. It's a web page that shows the top 10 of a certain hashtag that is being followed by our code. So it's .next. That's the final demo. We'll be using that hashtag, obviously, and this is also your chance to be well in a video forever if you send Twitter messages at the right appropriate time. So keep a Twitter message ready with a hashtag .next in it, and do make sure that you mention somebody with the @ sign and then some yourself or somebody else that you want to refer to, because we'll be looking at the people that are most mentioned connected to hashtag .next. Okay, so what will we do? We will create a distributed application, and we will start by making a piece of code that will monitor a Twitter stream. So that's the first part. Then after that, we will, because we need a distributed application, we will look at the most mentioned other side of it. So the Twitter monitor will receive messages, send them over to the most mentioned, and the most mentioned has a web API that allows it to show the top 10 leaderboard in the web page. Because it needs to show something to a lot of people, we obviously need some storage, and for this I've chosen Redis in this case. And whenever there's a message received, we will send it to the most mentioned part of the application. So those are two separate processes running distributed, and they will be called. To make it a bit more like a real life example, we'll introduce a bit of cloud technology, and in this case I've chosen Microsoft Azure. But what I will show you today, it can also be done using any other cloud provider. So whether it's Google Cloud, if it's AWS, or maybe Ali Cloud, you can use all of those as well. But first of all, we will put some secrets in the key vault because we want to keep things secure. And instead of doing this direct call from one to the other, let's take it a notch up and do a call over a service bus. Because if you want to build scalable distributed applications, there are situations where you want to do loose coupling, event-driven architecture, and just send an event on the service bus and then receive it on the other side. And then wrapping up, because we want to make it even better, then we have the Signal R server, which is a WebSocket implementation that pushes out notifications whenever the top 10 leaderboard has changed. So the web page can actually call the web API again. And obviously, because it's distributed, we want to do some tracing across the entire landscape and introduce something like Zipkin, but it could be other ones. So I've numbered them. We will not be going through them in this exact order, but close to it. But just imagine how much we would need to build and know about Key Vault, Azure Service Bus, the Signal R, building web APIs, storing in Redis, and knowing how to get messages from a Twitter stream, and then also tracing. So this is where Dapr actually shines. It takes away all the detailed knowledge of each of those things. Now, you might say, okay, but if I have a distributed application, I know about service meshes, and they can do a lot of heavy lifting as well, especially if you're hosting your distributed application in a container orchestrator, like Kubernetes, for example. Then the service meshes will help you on an infrastructure way. It's mostly for network operators or the orchestrator operators, people that work on that level, because it's mainly about networking, and it does routing, route splitting. It gives you secure both ways, secure transport, and it will do a lot of intercepting all of the calls going across the mesh. But in the end of the day, that is not a programming model, and they're very useful, those service meshes. Some popular ones are Istio, Console, and Linkerd. You can use those, but if you take a look at the other side, then there's distributed application runtimes, and they focus much more on the programmer because they offer building blocks. And in part, those building blocks overlap with what the service meshes provide, but they take it a step further. And if you start looking for the term distributed application runtime, it's actually something that Dapr invented as a term. There's a lot of frameworks and other programming methodologies about distributed applications, but the distributed application runtime is something that Dapr introduced. What does Dapr give you? Putting Dapr in the center of attention, because that's the main focus of our talk today, Dapr with ASP.NET Core and .NET Core background. But even if you are coming from a .NET Core background, Dapr is language and framework agnostic. So it allows you to build implementations from Java to C++, Go, and also .NET Core. And we will be focusing on the last part, because that's probably why you're at the DotNext conference, because you know a lot about .NET Core. So that's what we'll look at. Regardless of your programming language or framework that you've chosen, Dapr provides a number of building blocks. And I like to split them up in two categories: capabilities, things that you just get for free, and components, which are external things that you need to point to, such as secret management, pops-up mechanisms, or tracing. You need to do something for that, but the capabilities you get for free. If you have all this in Dapr, then you can choose where you want to run your application that is built on top of Dapr. And it can be anywhere in the cloud or on-premises. You can pick your favorite cloud provider. You can pick an edge infrastructure. That will all work. So that's for hosting your application. Each of the components that we'll see is sometimes also provided in the cloud. You can have it locally, you can have it in the cloud, and a mixture of both. So the components can also live on the cloud, where your implementation running might actually be running on your laptop or on premises. Now, Dapr uses and introduces this thing that is a sidecar, and it comes from sidecar architectures. That's a pretty well-known pattern. It's one of the cloud patterns, and I think it gained in popularity when Kubernetes introduced pods. And pods allow you to have sidecars inside of a pod next to your running container application. It has been used before for infrastructure, things like doing health checks or telemetry, because it is kind of a proxy. It has an ambassador and offloading capabilities, because you actually put something next to your application. So let's see. This is our .NET Core application, and here we have the Dapr sidecar. And when you've built your application, you can actually slide these two together. So you spin up your application and you indicate that you want to have a sidecar. And with the sidecar, that's I've called it a non-invasive connection to the application. It clicks in without you knowing it, but there's a lot to be gained if you can communicate with your sidecar. But that's the only thing that you need to take care of. Every work that you need to have done, you will just ask your sidecar to take care of it, whether it's calling another part of your distributed application. You will just tell your sidecar, contact this other service, and it will, by means of another sidecar, call the other sidecar, which contacts the other service. So think of it as a butler. That's presumably what the hat on top of the Dapr stands for, but you can also think of it as like the minions. There's a lot of minions running around, a little yellow, blue, and they're cheap. They can be added in an unlimited way, and they know how to talk to each other and take care of things for you. The end goal, and this is not what we'll be doing finally at the end, but going up from developing, finally you will run your Dapr application in a Kubernetes cluster, most likely. What you will do for that is prepare your Kubernetes cluster, pick up a namespace, and you will start adding special pods with container images that take care of things. There's a sidecar injector, we'll get back to that. There's one that takes care of where vectors live, That's also for later in the session. There's a certificate authority sentry that makes sure that all your communications inside of Dapr to Dapr calls are secure. And there's one that takes care of managing all the components that you will be using from Dapr. So this will be there. This is when you've prepped your system, this will be there. And as soon as you've built your application, then inside of presumably another namespace, you will create your application. You will spin up a container image inside of a pod. But because in your deployment file, you've added special Dapr annotation saying, I want to have a sidecar, then you will get, by means of the sidecar injector, you will get a sidecar injected next to your running application. And if there's another one that also has a sidecar annotation, it will get the same one. And after that, you're good to go. And the Dapr sidecars, they can talk to each other and they can do stuff for you. So you can have service discovery, mutually secure communication between the two, and also they will start talking to the components on the outside world. And there's a lot of beauty there, because all of these building blocks that are there, they are given to you for free almost by the sidecar. You don't have to know about all of the things from state management or publish subscribe structures. Your Dapr sidecar knows the implementation details, and you just ask your sidecar to take care of things. So let's make this just generic application code, and let's see what happens when we zoom in a little bit. So once this is started up, Dapr sidecar will provide a Dapr API, and you can interact with the Dapr API. You will call all of these special endpoints that correspond with each of the building blocks. And when you call the Dapr API, the sidecar will make sure that it uses the building block just as you've asked it from the Dapr API. If you look even a bit closer, you'll see that there's two endpoints that provide the Dapr API. There's an HTTP endpoint and there's a gRPC endpoint. And you can choose whichever one you want, but by default, it's the gRPC endpoint because that's the most efficient one in terms of network communication. Okay, looking at the components, because okay, we have the sidecars, we want to have components. The sidecar abstracts away all the component implementation details. They are declarative in nature, meaning that you will define what type of component you want to use for, well, for example, publish and subscribe. And there's a whole bunch of them, and the list is growing. So you can go from Azure Service Bus or Event Hubs to Google Cloud PubSub or Redis Streams, whichever one is in the list. For state management, for distributed tracing, for secret management, there is a lot of choice, and you don't really have to know which one is on the other side because you're only talking to the sidecar, and you don't actually know which one is on the other side, except for some tiny details, maybe in, for example, a payload that you have to send. Declarative in nature, what does that mean? Well, you'll be spending quite some time in YAML files. And one of the YAML files is for defining the actual components. And what you see here is that there's a component that we give it a symbolic name in the metadata, that's zipkin. And then you specify its type and some metadata details, whether this one is enabled or not. And those vary per component. This is a Zipkin exporter, which is for tracing. We will see that at the end. Next to that, you might need some bit of configuration. And in this case, it's configuration that says that we want to have a sampling rate for tracing. We'll get back to that as well later on. And then finally, those two are the configuration and the components are needed always. But as soon as you start running in a Kubernetes cluster, you will have special annotations where you will indicate, I want to have a Dapr IO enabled, meaning give me a sidecar and the application that will be running next to it is available on port 5000. And that is a certain configuration. The app config that is in the middle part right here, that app config. Now, to get up and running, what do you need to do? Well, first of all, if you want to run locally, you need to have a Docker installation. You use Docker Desktop, or you can have and you can have a local Kubernetes cluster if you want to. In production, you would need Kubernetes for sure. Next, you will install the Dapr command line interface, which is a download package that you install. It's cross-platform and you can use it anywhere, but it allows you to interact locally and with the Kubernetes cluster if it's hosting all the 4 services and any running Dapr instances in the cluster. Some parts are for Kubernetes only, and other things are for running things locally. And then once you have the CLI installed, then the final part before you're up and running is that you need to initialize the Dapr runtime. And for standalone running locally, it will mean that it will install 2 container instances. On Kubernetes, it will do all the 4 things that we saw in the previous slide. Now, before we get into the first demo, let's see what it means to run sidecars locally, because I think this is where you get started. You want to get to run this on your machine first, because that's where you can try out things before you start doing the complexity of a container orchestrator. So this is one of the projects that we'll be looking at. It's a web API project. It's an empty one, so there's not even controllers in there. But we have this special folder called components. If we build this and we want to run it, we can use the Dapr CLI to say, okay, run this application with a particular application ID, the port that 5000, meaning that's the port that our application will be running on, and where the path to the components is. And because it's ./components, running it from the root of your project, where you can also do .NET Run, it will spin up .NET Run and attach the sidecar to it. And this is how that goes. So you have your application code. This is both started by doing Dapr Run. Dapr inspects the components path, and in this case, it's the local one, and it has 3 YAML files. So 3 definitions of components that are there, and it will try to get those started and initialized. Once it does that, it will start looking for port 5000, because we've indicated that at 5000, our application would be running. And as soon as our application from .NET Run comes alive, and it says listening at port 5000, then Dapr knows, okay, my application is there. This is the reason I'm here. So here's my Dapr API. And from that moment on, you can start calling it. This is the life cycle at the start. Now, almost there, we're going to see some code. But the Dapr sidecar doesn't know about any programming languages. It offers the 2 endpoints, and it's just a REST interface that you can call from any language that you want, as long as you can make HTTP or gRPC calls. We're .NET Core developers, and so most of this relies on ASP.NET Core, and that's why you'll get a number of builder extensions from the NuGet packages. You have state model binding inside of your controllers, for example. You can bind to incoming HTTP requests and get your model deserialized. You get the actors as a capability in ASP.NET Core as well. You'll get some cloud events middleware and ways to do subscription on PubSub. There's even more actor stuff. There's state management coming in. And then you have the configuration where let me get this out of the way just a little bit, where your configuration data can be stored into a secrets store. And then finally, we have something that is very valuable, the Dapr client, because that's the way that we, from our code, can communicate with the Dapr sidecar. And as you know by now, talking to the sidecar means using all of the components and capabilities. So building our application. Remember that we wanted to do something with the Twitter feed for #.next. So what we'll do first is we'll start on that end, and we'll do input bindings first. There's input and output bindings. Some of them support both. The Twitter binding is a input only, so it's kind of like a trigger. You see the YAML file on the right-hand side. That is what we will be using. And then inside of our code, all we need to do is map to a handler, meaning that if you go back here and you see the metadata name for tweets, that's over there. Then here you can see that we are mapping the post to tweets. That's how an input trigger is actually being handed over to our bit of code. And you see here the handle Twitter message is the delegate that is indicated here. And that's one way of doing this. The other one, if you have a controller inside of an API controller for MVC or a web API, you can just do an HTTP post for the particular route as an annotation over your method, and the method can be any name, and there you can start handling the tweet. And this is where you will get some model binding on the tweet structure that comes in. Okay, so let's start looking at that bit. So we are going to look at input bindings first. So we have a default web, an empty web project in ASP.NET Core, and we will start doing attaching to a Twitter stream for .next, and then have the sidecar available as well. And let's see what all of that takes. All right, let's go. So here is that Twitter monitor. It's an ASP.NET Core 3.0 application. It's a web application, so it uses the web SDK. And I have a couple of NuGet packages for the client and ASP.NET Core, and we'll be needing those. Now, in our program, if you start looking there, this is actually pretty boilerplate. There's nothing special there. And inside of our startup, as you can see, there's this thing about the Dapr client that we'll need later on. But down here, there's actually only the bit of code that we saw in the slides. So we have tweets as an endpoint, a route, and we're handing it over to the handle Twitter message. Why and when will this be called? Well, that's because inside of our components folder, we have the Twitter binding there. And the Twitter binding has connection details. So it has your key and secret. These things vary per type of binding. And in this case, we have #.next. Now, if you didn't do it already, start preparing a little Twitter message with #.next and mention someone in there. Well, that doesn't even matter for the first part, by the way. But let's see if we can make that work. But how do we get all the Dapr goodness? So let's go to a window here. So I'm inside the folder that has the code. So let's see if we do a dir, then we can see that we're actually inside there. And here's our components. And what we will do now is first do a Dapr init. This you only need to do this once. I'll show you why. Because if you do Docker PS, you see that I have no Docker containers running. But if I do Dapr init, it will start downloading the Docker images that it needs, and it will assume that you need two things, Redis store and Redis streams for PubSub. So we'll download these, and it will start the two container images. Then you have two containers running, and those are the backbone for what you most likely need. So if you do Docker PS again, you'll see that there's a placement service and Dapr Redis. Those are available for you to run. The Dapr Redis is the storage. The Dapr placement makes sure that actors and all are being placed. Well, we're not going to talk about access just yet. All right, so now let's run our application. So we're going to do Dapr run, the ID Twitter monitor, port 5000, and then point to our components path and do .NET run here. And if we run this, we will see that this is going to bootstrap. So it already found a couple of components, as you can see, the tweets binding, the state store, and the message bus. And now it was listening at the application. So it says waiting for port 5000 here. So it will wait. And then our application started to boot because we're listening at 5000 here, and we're good to go. Now, let's see. This is a lot of messages, and then finally it says, we are waiting for incoming Twitter messages. So if you send a message now, with any luck, we should see something happening here. So press send now on the Twitter message with #.next, and let's see if there's something popping up. This is an exciting part, I think, because this is a live demo, and it's kind of depending on anyone sending a Twitter message. We'll give it a little bit. And if it doesn't do anything, well, okay, then it doesn't work. Do notice that we're running outside of Visual Studio now, so debugging is kind of hard. We'll get to that because it is so much more valuable. You can, if you can do debugging. For now, what you can do is attach a Twitter message. Attach a debugger to the running instance, and that should all. Let this run for a bit, and we'll get back here after we've done a couple of slides. And maybe there's been some Twitter messages. Let's hope. All right, back to some slides. Because this is just to get started. We're actually using the sidecar that will take care of connecting to Twitter and push the messages to us, which is also why we need to expose an endpoint. But normally we will be calling the endpoint of Dapr. It's sidecar. So again, the API with all of its endpoints and endpoint URLs that is there. Let's make this .NET Core code. And what we would like to have, obviously, is a strong type proxy, because we're used to working with something that we can call from C#. And making HTTP or gRPC calls is kind of awkward. So that's why you get this proxy that will help you call those methods by means of the HTTP or gRPC calls. You will add a number of NuGet packages, presumably, but most likely the Dapr client, because that's the one that holds the proxy, the Dapr client class. If you have this one, you will get this proxy thing that looks like Dapr. You can talk to it, but it actually translates method calls into network calls going to the sidecar. Now, here's a bit of code that you will see once you start using that. We already saw the add Dapr client, and I'll show that again, but there's a lot of configuration that you can do. But once you've done this add Dapr client in your configure services during startup, then you can resolve the Dapr client by the usual ways, which is doing it with a method injection or with the from services per method call. And once you have the Dapr client, there's a whole bunch of things that correspond to most of the building blocks and components that we have, such as retrieving, deleting, finding states, invoking methods, or doing PubSub. So how does that work for PubSub? Given an event bus or a message bus, any type that you want to choose. These are just a number of them. There's much more, but these are fairly common. So Nets, RabbitMQ, Redis, Azure Service Bus. If you have a piece of application that is considered to be the publisher, you can push stuff to the sidecar, and you can make a call with your Dapr client doing a publish. Then it will send to the topic of your choosing, it will send a message. And a message can be an event by its meaning, but it doesn't really matter. It's just a message that gets sent to the bus. And on the other side, you can have a piece of subscriber code. And if it also has a sidecar and you point it to the same event bus and topic, you can have one or more subscribers listening to the message bus. And whenever the sidecar of a subscriber sees that you want to have a subscription, it will register a subscription on the bus, meaning that whenever there's something published, it will get delivered to both subscriptions, and each of those subscribers can pick up the message. This allows you to do competing consumers, or it can do a resilient, loosely coupled connection between one side of your application and the other. So the sidecar receiving the message will push that into your code by calling a method that you've indicated. Now, the messages themselves, they are containing a bit of data. So you see here the tweet ID of user and the username. This is whatever you push into the message. And the rest of it is just the envelope, which is a cloud events envelope. And it's used as the carrier to make sure that it gets delivered and there's a bit of tracing. Because, for example, here, this bottom one is, I believe, the W3C tracing header. Now, if you want to publish a message, then that can be done in a number of ways. For testing purposes with the CLI, but in your code, you can use the Dapr client and just say publish event async. And then you push it to a particular topic. That in this case, it's tweet. What you want to push is a bit of data, an object of type tweet. And if you put that in here, it will be serialized given the JSON serializer options, and that gets injected into the cloud events 0.3 envelope, and you're good to go. On the other side, if you're preparing for subscriptions, then you will at least use this use cloud events, because that will actually take away the envelope on reception, and it will get you the payload. And the map subscribe handler is a way for Dapr to know which subscriptions you would like to have. And the map subscribe handler does an enumeration of everything that you've indicated as a subscription, and give it as a particular endpoint /Dapr/subscribe that shows in a JSON structure all the subscriptions that you would like to have from your subscriber application. How does it know which ones are there? Well, that's because in your endpoint mapping, you will map to on reception on the topic of tweet, do a post, and then you will say, okay, it's from the topic tweets, but we will send it to this route tweet. And here you can see the same in the controller action. That's the alternative of mapping. You mention the topic that you want to listen to, and you have your route as an HTTP post. And that should be enough to get to deserialize your tweet message that you know should be in there. The beauty of this is that you can actually split the topic from your route. So there's a couple of places where there's the topic mentioned, T, and the route can be something different, giving you a little bit of more flexibility. Now, let's do that in the code as well. Let's build this part of the application. We will do the other side, so the code that is most mentioned. It's a web API project for reasons that will be obvious later. But for now, we will just do push out, publish a message on Azure Service Bus, giving us the building block for publish subscribe on the left-hand side, and also for subscriptions on the other side. So let's see if we can make that work. And I do see that a couple of messages have come in, so thanks for those people. You know when you've done those, and I'll stop this for now. So they will be lost in the overall leaderboard later on, but we've stopped it now, and our application shut down, and the Dapr sidecar also shut down. So we're back to running nothing. Okay, let's see. We are going to go here. So we still have the Twitter monitor. Now it's time to look into what is happening when we receive a Twitter message. So in here, this is more of the raw way of doing things, because we're mapping here to this handle Twitter message. We're giving an HTTP context, so that's, you can't get any more close to the network stack than this. And you can just deserialize your body if you know what thing is inside of it. So we're deserializing the tweet. This is where the log information came. And then we're saying, okay, because we can't really look into what is inside of the binding, we need to have a configuration for the monitor tag, which is actually down here. In this case, it's Microsoft. And I will be changing this thing here, and I'll explain why this is Microsoft for now, but it's for testing purposes. But this is the thing that you need to do for publishing. You publish an event, and the event will use is tweet received. Tweet received does nothing more than mention the tag as the monitor tag that we have. So that would be Microsoft, #Microsoft. And then we put in the entire tweet. Now you can do some mapping and anti-corruption layering here by having a DTO versus your internal model. That's all up to you. But in this case, we're just taking whatever came in, because we have those objects here. So that we have the hashtag, the URL, the tweet, and so on. And this is the object model for a Twitter message. Now, when we've received all this, so we publish this event onto the bus. Now, how does it know? How does it know where to publish? And it says here mentions. So that's where in your publish subscribe definition, you have message bus here. But let's go to another place. Wait up. Components, and here is also PubSub. Okay, so this is the actual one that's being used, and I'll explain in a bit why that is. So this is registered as the thing. We give it in the code. We say we want to publish to the topic of mentions and the data in the message that we want to push out. And that's actually all it takes. Now, on the other side, we have a web API project. And in this this one here, we have a bit more of code. So there in the program, it's pretty default. We'll look at that later. In the startup, we're doing a bit more. So first of all, we're adding controllers and Dapr so that they can work in unison. And this add Dapr also registered the Dapr client. For the rest of it, there's not much to be done except for the cloud events and doing this map subscribe handler, because that takes care of providing a list of all the subscription we want to the sidecar. And then we have this most mentioned controller, and this controller has this topic here. So it says I'm listening to the topic of mentions, and I'm redirecting it to a post for mentions, which could be something else, allowing you to call this over an HTTP post if you wanted to, or when there's a message arriving, it will also use this one. So this topic mentions is reflected on when doing the map subscribe handler, and then it's all connected together. And here we just receive the message and deserialize it automatically, so we don't have to do anything. And we have the from services. From services allows you to inject a Dapr client only when this method is being used. So it doesn't do it for all of the other controller actions, just this one, because we will be using it. And what we will be doing, we'll see in a moment. But here you can see that it will say that it received a mention for something. Somebody that was being mentioned in the, this is actually a Twitter message, so I'll make that better. Twitter message from, that should be it, because it's not the mentions. And the rest we will look at in a bit. Now, in a moment, I will press F5 and I'll run a Docker Compose file. Now, this is where things get really interested if you have been using Docker Compose to run things in a container, because we have Docker files to build everything in a container, but the Docker Compose is running the Dapr Web API as an image by using the file I just showed, the Docker file, and then doing all of these things, and also run a container with a sidecar. And the tricky part is this network mode here, because it says, put me in the same network as the web API that I'm connected to. So they're very closely connected. And if they say localhost, they're actually pointing to one another, which normally couldn't work because of the network isolation. So that's there. We override the placement card that we need. And we have other things that we'll need later on, like Zipkin, Prometheus, Grafana, Redis, and here we have the Twitter monitor, where we do the same thing. So we want to run our other, the monitor application inside of a container. It depends on Redis and placement, just like we saw when we ran it standalone from the command line. And again, the sidecar container image that just uses Dapr d.exe with all this configuration that is pointing to this other placement location, and indicates which ports are being used, and also doing, put me in the same network as the one that I'm connected to. So this is the sidecar being connected to the Twitter monitor. We have one network, and we use Grafana storage to be permanent. Now let's see if this is going to work. So a couple of things. Let's see. So we have this tag being provided for Microsoft now, and the Twitter binding that I'm using for running in Docker Compose are actually here. So here is the Dapr Web API components, and here is the other ones. And for the Twitter binding, I'm using #Microsoft because there's more activity going on there, so we can actually see a lot of things happening. Okay, fingers crossed, and let's see what happens when we run this. So what it will do now is it will compile all of the assemblies. It will rebuild the container images. That should be pretty fast. It will run Docker Compose, and then it spins up all the containers, the other ones that are there. Here it's creating the images, the instances for the Twitter monitor and the web API. And if all goes well, it should start debugging now. And this is really neat because now we can hit some breakpoints when we start this up, even though all the sidecars are being connected. So I believe I've put some breakpoints in, which we should hit pretty soon. There we go. This is the bootstrapping of one of them and the other one. So after this, they should both be running, and it will spin up a web browser with the web API. Well, the web API we'll get to later, but let's see what is actually happening underwater. So I'll spin up this thing here. This is the Twitter monitor, and what it is was it just did its normal bootstrapping, and you should be familiar with all of these things. Now, whenever the messages, if they start coming in, we should see them being received here. Once that is done, it will send them to here, and there you see that the other ones were already pushed out onto the bus, so they were waiting, and now they've been collected on the other side. So this is a proof that the two messages that we received earlier are now being handled, even though there was downtime in parts of our distributed application. Now, let's see if the Twitter connection is working for the #Microsoft. It sometimes takes a little while to get things in. But let's hope that it works. There's actually one coming in now for Microsoft. If you want to look at what the sidecar is doing, it's these container images that have this Dapr_1 to it. And here you can see, finding all of the components, which is what we discussed, and a lot of debug output. I've actually put it to the info level or debug level, so you can see a lot of things like removing messages, and following signal R, so everything is already there, and we'll look at it one by one. All right, so yeah, Zipkin running, everything doing fine. So we see that the messages coming in are also flowing because there was a message coming in. You should see there's more coming in, and they are being received on the other side. Let's put a breakpoint. As mentioned, let's put a breakpoint here. And whenever the one comes in, we can actually see this being hit. So it's coming from the monitor over the bus. Let me see if I have this. You can see the activity here. So if we do a refresh, this updates a bit slowly, but here's where you can see all the messages coming in over the leaderboard. And this will hit a breakpoint fairly soon, probably. So let's continue with some slides. Okay, pops up done. That was number 2, going to state storage. And if you want to store state, okay, let's clear the breakpoint and do F5. So that's working, that's good. You need to use the API again. And in this case, the URLs are post for storing data at with a payload that has the key and the actual data, and with a get or delete, you have a URL that is formatted with the store name in it and the key. So it's pretty basic, and it follows a RESTful pattern. If you call those, whichever state store is used, you can define and pick and choose any one of them, and you can even replace them because you don't have to know. Just look at the URLs; they don't actually contain any information. Now, if you have a component definition file, Then inside of it, it says now state.redis in bold, meaning that we will use Redis. And its name is called state store. Now the name is important because that name will be used in your code to indicate which one that you can have, because you can have multiple stores. Now there's more to be said about state storing because you can have consistency levels of eventually or strong. There's optimistic concurrency controls using the E tag headers. There's a resiliency for making retries and exponential backoff, for example. So there's all goodness for doing state storage in a scalable, robust way. So remember, state store is a name that you will use in your code. Inside your code, and I will skim over it and I'll show you in in Visual Studio. But there's again a couple of ways for you to work with the .NET storage. So let's do that. Let's go for part 3. We want to do the state building block, and store into Redis. And I think you might already have seen it if you were looking at the lines after the breakpoint that we set. So let's do this here. This is how easy it is to do storing of state. So if we hit this breakpoint and there's another one coming in, this is the store name, and it says state store, like we've defined, and we get this message in with tweet received. It's for the hashtag Microsoft because we said so, and this is the details with the username somewhere down. And then we see the user is another object that has, well, this stuff in it. So that's where you get your data. Let's move over to this one and see if we can hit that breakpoint. It only happens when there's a mentions inside of a Twitter message, but there we go. What we want to do now is retrieve a state entry. And a state entry is looking for how many times has somebody already been mentioned. We know the unique name of the mention inside of a Twitter message. And if we get this and we don't find anything from before, then we say, okay, this is a new mention, and we start at 0. And then we can just say, okay, you've been seen one time again. So this is where you actually start increasing your score because you were mentioned again, or your account name was mentioned again. And then you just save the entry, saving back what you retrieved. So you don't have to know how to store it. It's just all in the entry with its key and value. That's all there is to it. So let's get rid of the breakpoint again. Do F5 and let's go back. Okay, then because Dapr is also about actors, a short bit on actors. There's so much to be said about using an actor model. There's Orleans, there's the service fabric actors or reliable actors. There's other like Akka.NET, for example. They all have actor implementations, and most of them take care of doing single-threaded access from inside of the actor, making sure that no two calls are made at the same time. Now you get the actors that is very close to the actors from Service Fabric. Mark Fussell is the program manager, and he used to be on the Service Fabric team. So he carried over all the knowledge of how Service Fabric is doing actors and put that into Dapr together with his team. Now, there's a rich programming model. There's reminders and timers that allow you to have callbacks after a certain time, persisted or not. And you have a placement service that makes care of distributing the actor instances. So if you ask for a particular actor, it starts living somewhere, and then the placement service makes sure that it's nicely spread out and instantiated at the same point every time and again. Well, there's more details. Couple of things to note: that if you can only have one store, if you have multiple stores, that has the state store for actors, and that's in bold here. One of them can have true, the other should have false, which is the default. And you've seen the pattern before. So if you start talking to the sidecar, you would do that from a well-formed URL. In this case, using actors, it's type, the unique ID, and the method that you want to call. And in your payload, that will be the whatever state you want to put in. Now, again, the demo. So a couple of things that we'll do here. We'll create a web API that retrieves the state from an actor, and we'll use actors to store the data for a leaderboard. So whenever we can receive a message inside of our web API, it will increase the score and then hand it over to the actor that is particular for a hashtag. So now in this case, we want one for Microsoft, and it will check if the score is high enough to reach the top 10. It does do some state store, so we'll look at that at the same time as well. Now, okay, this is where that starts to happen. We're in the same message again, the same method, which is the handle of the mentions. This is where the tweet received came in. We stored it, and then we say, okay, inside of the tag, which was Microsoft, get the actor taking care of the leaderboard for Microsoft, and create me a proxy. And the proxy is the way so you can communicate with it, this being the actual implementation type. The implementation is here, leaderboard actor. And in the leaderboard actor, you need to have a special constructor so it can actually be created. It uses the actor ID, which is the unique ID that you want to, that is used to retrieve the data. And then you can have multiple methods that define what the actor is actually about. So we have a get ranking and a submit score, which come together in this interface for the actor, derived from iActor, which is from the namespace Dapr.actors, and you have your submit score and your get ranking. And those are implemented. So whenever from our most mentioned, if we make this call here to the proxy, we do submit score. And we've just calculated the new score with the plus for whoever we found were mentioned in the Twitter message. And then we just say, okay, submit the score to the actor. And this will be single threaded inside of the thing. So this doesn't mess up if we're actually manipulating the list, but there can't be a race condition or whatever because there's only one thread allowed inside this code at a time. What we'll do is we'll use the state manager that you get for free inside of the actor, try to get the state for a leaderboard entry list. And then we'll check if it has any value. If not, there's apparently no scores yet. We will remove entries from the one that we're trying to increase now, add one, and there's probably much smarter implementations, but this is the most straightforward, I thought. And then finally we say, okay, actor, store the state, because we will only take the top 10 in this case, the max entries, and store that in your state again. So we're getting state from the actor, manipulating it, storing it again. And in our get ranking, we can actually get the top, whatever you indicate as the argument in the method. So the top 5, for example, as a list returned from our actor. So this is how you can query, or no, not query. So here's how you can ask the actor for its state, but maybe not all of it, just a piece of the state. And there's a leaderboard controller. That's the web API that has the get for most mentioned with a tag. It also does the actor ID, creates the proxy, and simply returns the serialized JSON for the ranking list of the leaderboard entries. Now we should be able to see all of this because if we go to here, here we have the Microsoft tag in the URL. And if we press F5 here, we can see that there's actually these are the things that were being picked up. And apparently Microsoft Azure is being mentioned a lot in combination with hashtag Microsoft. All right. Let's see. This is, I think, what I wanted to show you about the actors. All right, let's continue. Now that we have a lot in place, so we have a web API, we can build a front end to that, showing you what is there. Now, it would be really neat if we could do something on the way out, if we are done with handling the message. And in this case, I thought it would be nice to show you a bit of signal-R and push out a notification to a web page that was showing the the leaderboard, because whenever it changed, we can indicate it to the browser that it should requery the web API and refresh the list. Now, there's a bunch of output bindings that I've mentioned to the right. These are actually the names that you can put after the bindings dot. So you can do Azure signal-R, but you can pick any one of the lists that that fits your need. And in this case, it has some metadata with the connection string to the signal-R server inside of Azure and the hub that we want to use, the leaderboard hub. And whenever we want to use the binding, you do this invoke binding on the Dapr client. And it has a signal-R to refer to the signal-R here as the name of the component. Create is an operation. That's the only one that is supported. It's required, and you just say create. It doesn't actually mean something. The data is what it's all about. Now, this was pretty short, so let's introduce the front end. And I want to thank my colleague Thijs Limme, who knows about JavaScript and Vue.js and other stuff in the browser. He built this nice user interface and created a connection to the Azure signal-R server, which we will also be using with output binding. So in our startup, we have a little bit of code to do a couple of things. So first of all, we do this add signal-R, add Azure signal-R. That will read the configuration and use this endpoint to connect to a hub that I've created on Azure. It has some more code saying, okay, this is what I need to do to provide an endpoint for the hub, for the page to call into, so the web page. And then we are pretty much good to go. The only thing that we didn't show yet is in the most mentioned controller is after that we got the rankings from the actor. We're composing this a bit of signal-R invocation data. I made this up. This is my class, but it has a target, which is the message that is being pushed to the hub to all of the listeners with an argument that is not really relevant. So forget about that one. And then we do the invoke binding async. Now that ends up, and I'm not going to show that too much, but here is the single index HTML page that has some libraries for signal-R. And it has styles, it has stuff, it has bindings here for the list. And most importantly, it has some connection details to what we are doing here. So we'll show that in a bit. And then the rest is just connection stuff, but this is the broadcast message. That's actually saying something has changed. That is what our invoke binding async will trigger. And that should look something like this. So this is the page, and this is what is actually being shown. So if we go back to here and we do F5, we see number 1 should be Microsoft Azure. Let's see if this is also the case. Microsoft Azure at the top. And whenever something is changing, it is actually being pushed out here, and you will see a nice animation here. Let's start prepping this for, I'll turn it over to .next now. So let's go to the index again and make this .next. So all messages being tweeted with hashtag .next. That's one place to change it. We need to do it here as well. So that's .next. And then finally, to make it all work, we need to mention the hashtag here. There's probably room for improvement, but this will work, and I'll reset it. Oh, I might not reset it after all, so I'll just start it again and do the next part of the slides. Secret stores, so I'm just rushing on for the interest of time. Secret stores are a way to keep the secrets out of your implementation. Again, it's endpoints that you can call, and you can use this Dapr client get secret async to get at a particular secret, but most likely, if it's about configuration data that you want to keep secret, you can use the configure app configuration and then say, I want to add, like you would do, add a JSON file or add Dapr secret store, and mention each and every of the Dapr secrets that you want to retrieve. So it doesn't need to do a list on all your secrets that are being stored. It only does a get, and you need to know the names of the secrets that you want to put into your configuration. And then you can just refer to my secret from your configuration system. This will be a short one, Azure Key Vault. How did we do that? Okay, this is starting to work. We have, in the web API, we have a key vault definition. So it has some details, but the actual stuff is in a certificate file, so you can't see all the things you need to actually connect to it. And then inside of the code, it's as easy as, well, you can do two things. And I left this out because this will be a blocker if this doesn't work. So let's get the breakpoints done. Go back to the program CS. Here you can have the bit of app configuration where you load your secrets. We didn't really need that, so I commented it out. And okay, there's our web API coming to life. If we change this to .next. Now empty, but it might just fill up pretty soon. And that means that if we go here and we do F5, this is also empty for now. All right, so the secrets are going to be here. If I am looking for the place where I put the secrets. So here we have an endpoint of secrets. It does the get secret async from the key vault, the name of the component, and the secret that we want to retrieve. And then we get it. We get back a list, because some stores actually give back a bunch of secrets based on a key. In Azure Key Vault, it's only one. And then we can pick the secret value that is in there. And if you go to this here, then it's already showing the secret, but if we press F5, we can see we hit the breakpoint, and then we can see that the secret values are actually containing one, and the one secret that is there is the key and the secret retrieved from Azure Key Vault. All right, we're about to round up. Last part is about tracing, that if you want to do tracing, a service mesh can only do tracing whatever goes across the mesh. So that's only direct calls from one sidecar to the other. That it would be able to pick up. But the beauty of Dapr is that it can also trace across an external message bus, such as the pops up that we've done. It has an interceptor on the sidecar that monitors all the traffic going out, whether it's direct or from pops up, and pushes in some headers. And then it uses OpenTelemetry to do tracing at the back end. There's other ways of doing it, because if you do string-based tracing, then it's for testing purposes. But if you go for native, it will allow you to do OpenTelemetry style things such as Prometheus, App Insights, Jaeger, and Zipkin has its own direct one. So it doesn't, that's directly to Zipkin. We have been using that for a while now. And let me get this one out of the way. You might be seeing stuff here. Oh, okay, so there's already tweets coming in. Good. There might be more in a bit. And let me think. Oh, here's Zipkin. So if we go to Zipkin, we've been tracing all along, and this is where we can actually see what is happening. So let's pick one. And then you can see the tracing from the Twitter monitor that received something from the Twitter trigger. And then it pops up on mentions, and it got accepted. And there's the call to the actor that was being done. Probably there weren't any mentions in there, so it immediately went to the get ranking. If we go back again, maybe there's a more interesting one with more calls. Let's see, maybe this one. Here you can see a mention, then a submit of score, getting the state from an actor, and ranking. Okay. I will be finishing up. So we've seen quite a bit now. There might be more coming in, so I'll push this to the side a bit and start doing the final things. We've looked at the tracing. You need to do a little bit of setup, but actually you don't have to do any programming. So that was the demo that we already did. So we're finishing up. I hope that you've seen that within the time span of an hour, we've been able to whip together an application that is both distributed, uses a lot of cloud components that we didn't have to learn about. And if we start replacing YAML files now with other things, we actually can switch from Azure Service Bus to MQTT, for example, and there's hardly any code changes, if at all, required. The same goes for hosting your application in one cloud provider or the other. If you're running on Kubernetes, which is the final stage of what we could be doing here, then you're actually pretty portable in terms of code and the components that you can have. Dapr is still evolving. There's a lot of traction there, a lot of investment. It's changing every 2 weeks, and then there's a community call. So if you want to contribute, and if you're a Go programmer, you can actually contribute to the core, or maybe you can help out with writing community contribution components, such as all of the bindings that were there. If you have one, then they will be lovely. They will be likely to accept your pull requests. Here's some resources that you can look into. This is what got me started and reading about the things. Do check into the bi-weekly community call, because then they'll do their end of sprint review and show you the cool demos of the things to come. That is what I have for you today, and I'll be ready for any questions now. And I'll put up the list here, and maybe we can see some things coming in.
Yeah, we could start. Actually, someone is writing a question right now. Anyway, we could start with short discussion of the topic you're not really said much about. So you said that's a great tool, you've shown plenty of great things and so on, but you're not said about any problems. So what are the cons of using Dapr? What thought could happen? What problems maybe you met?
So the downside of using Dapr.
Mm-hmm.
Okay, well, I think that with every layer of abstraction that's being introduced, you lose a bit of directness to whatever you're using. So if you want to have, it's like this least common denominator that you get for pops up, because can you do, if you know the exact type of your service bus, can you get more performance out of it or do optimizations? Well, yes, you could, but now with Dapr, that's all abstracted away. So you can only do this publish async method call, and you can give it a little bit of metadata, but that's about it. So there's not too much, there's not much leaky abstraction there, allowing you to get your hands right inside of the actual component implementation that you want to use. So I think that would be a downside. The other one is that currently this is being used in production in places, but it's not the 1.0 release just yet. It's 0.8. So it's getting close. I'm not sure what the actual timelines are and the roadmap for the team, but this is still maturing and getting production ready. So that's, can you use it now for production? Officially you should say no, it's not on a 1.0 supported release yet. Can I think of other things? Well, yes, so since it's evolving, you notice that there are sometimes breaking changes as you move along from the previous version to the next one. Not too big, not too dramatic, but something you need to take into account. I hope that answers the question.
Yeah, actually there was another question on kind of same topic. So Amal Shor saying you thanks for the great demo. He says it was very nice. And his question is, how much overhead does it add?
Okay. How much overhead does it have? Well, it does have the overhead of a network call, because whenever if you're using the direct APIs or if you're using Dapr clients, it will issue a network call to the other components. And so it's deserialization, and a little bit of network traffic. Since it's by default gRPC, that's very performant, but still it's not the same as an in-memory call to another part of your implementation. So that's from your implementation to the sidecar, and then after that, it's what you would always pay, the whatever time it takes to an effort to put it on a bus or make a call to your other component inside of your service landscape. Those are the same always, but it's the calls that you make to your Dapr sidecar involve a network call.
Okay. By the way, always when we have a network call, it's not only about performance, but it's always kind of about reliability, because any network call can fail. So could it be kind of overhead problem downside, something like this?
Yeah, well, true. There's all these resiliency patterns in place. So if the call doesn't succeed, they'll try to make it again, and you can tweak how the call is being made. So so how often it's retried, if there's a timeout that increases and all. That's indeed overhead. But I think that's, if you want to have a resilient, robust application and you know that it's distributed, it's the pain you have to take. You can't really do without that, because otherwise, if one service goes down for just a fraction of a moment, then the other components would suffer as well, unless you have the resiliency patterns in place, which are very common in distributed application design.
Okay. Another question from Mike. Do you have event store connector or binding?
Event store. Well, let me go back to the slides, because I believe I have a slide in there. This is for the, let me see which ones are there. So event store I don't see in the list, but it doesn't mean that it's not going to be there, because all of these bindings here are actually community contributions. So that's how you will find them in the GitHub repo for Dapr. Meaning that if you know how to communicate with event store, then you can actually ask for or create one yourself and contribute it, and then the community effort will probably get it to production level.
Okay, and now he asks, maybe there's a way to mix it with Istio, for example, so use some other tool for this purpose.
Let me think. Istio. Yeah, yes. So Istio is one of the meshes, and the meshes that the service meshes you can use in tandem with Dapr. So they are likely to work together. There's even articles on GitHub for doing that. There are some overlaps, so they both work on telemetry and tracing, where Dapr has some richer tracing. And let's see, yes, so I think that the mutual TLS is also what they both provide. In summary, if you have Istio, Linkerd, console, then you can use that and add Dapr on top of it. But you can choose whether you want to use the tracing from Dapr next to the service mesh tracing, or leave one or the other out.
Okay,
so I have to interrupt you. So since we have very hard deadlines, just to remind you that we can continue discussion in Zoom. Thank you, Alex. Thank you, Roman. See you there.
Bye. See you guys.
Okay. Thank you. Bye-bye.